All right, here we are doing section 8.5, factoring special products, specifically perfect square trinomials and the difference of two squares. So we're actually going to start with the perfect square trinomials. So when you look, let's highlight those words there. Perfect square trinomial. And what we have to do first is check to see if we have a perfect square trinomial. I have set up a 4-step process, as you can see, and it looks way worse than it is, but I have it written out so that it'll be clear. So first thing you want to check if you have a, first of all, trinomial, that's 3 terms, 1, 2, 3. But the first thing you want to see is that a perfect square. In other words, when you take the square root of it, will it be, can you do that? And the answer is yes. You can always have a perfect square on the x if it's an even number. And then the number before it, it's one of those perfect squares that I showed you a few days ago, like 36, 25, 16. Those are all perfect squares, so you would need that number in front of it. So that's the first thing. So it's like, is that a perfect square? Check. That's not bright enough. Check. Then we look at the last term. Is that a perfect square? Check. Then we look to see if that second sign is addition. Check. So far they're pretty quick checks if you know what to check. You're checking that, checking that, checking that. Now this one's a little more complicated, but we call this the smiley face. So when you take what is the square root of x squared, you get x. Square root of 36 is 6. So now you're going to draw your smiley face. You're going to multiply and get 6x. You multiply it by 2. So every time, this isn't specific to this problem, every time you take whatever it is you get and multiply it by 2. And this should match that. And it does. Check. So now we can factor that. So we are going to finish this off. So this is set up like a smiley face. So now you need to put the nose in there. And this is the nose, the plus sign, or if it was subtraction, it'd be subtraction. And these are the ears. And this is the little top hat. So kind of strange. My class last year helped me come up with that. But it works. My answer to this question is x plus 6 squared. So it's x plus 6 times x plus 6. I would accept either. They're both the same. Okay, so let's try that again here. Determine whether each is a perfect square trinomial, and if so, factor it. So first of all, they should have 3 terms. If they don't, the answer is no. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes, they're all trinomials. Now, we got to do the 4 checks. Is that a perfect square? Yes. Square root of x squared is what? You write it. X. Is that a perfect square? Yes. 2. Is that a plus sign? Check. So I've done 3 checks. Now we make the smiley. Multiply them and get 2x. Times it by 2 and you get 4x. Does that match the middle term? Yes, it does. Check. So we know now it is a perfect square trinomial. Boom, 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 boom. Now we just have to, if so, factor it. So we need to seal the deal. So put the nose on. Put the ears on. And the top hat. So we have x plus 2 squared. Let's try the next one. Is that a perfect square? Yes. Check. Is that a perfect square? Yes. Check. Oh, wait. Yes. Is this a plus sign? Check. Now we make the smiley and do our last check. Multiply them and get 7x. Times it by 2, 14x. Does that match? Check. Doesn't matter that there's a subtraction in front. So we have a perfect square trinomial. Time to make the face. Put the nose on, now it's a minus. Put the ears on and the top hat. X minus 7 squared. How cool is that, you guys? So you know this is the same, right? This is the same as x minus 7 times x minus 7. This is the same as x plus 2 times x plus 2. Let's try another one. Perfect square? Sure is. Square root of 9 is 3. Square root of x squared is x. Perfect square? Yes. It's 2. Check mark? I mean, plus sign? Yep. Now we make smiley. Multiply them and get 6x. Times it by 2. 12x. Does that match? It does not. Not a perfect square trinomial. Okay, if any of those four fall, you're done. Yeah, if right off the bat, you couldn't do this. If this said 5x squared, no, done. Because 5 is not a perfect square. If I had had that instead. Done with problem at that point. Let's try another one. All right. How about this? Perfect square? You bet. 3x. Is this a perfect square? Yes. 8. Plus? Yes. Check. Now do our last one. Multiply 24x times 2 is 48x. No. Not a perfect square trinomial. Okay. Next, perfect square? Yes, 9x. Perfect square? Yep, 5. Plus, check. Now, we do our smiley, 45x times 2 equals 90x. Yes, it matches. Check. Now we just need to factor it. So put the nose on, plus in this case, put the ears on, and the hat. So we get a 9x plus 5 to the second power. Or that can be written as 9x plus 5 times 9x plus 5. All right. One more. Is that a perfect square trinomial? Yep. Is that a perfect square? Not a perfect square trinomial. Is that a perfect square? Yes. 6x. Is that a perfect square? No. Not a perfect square trinomial. That makes sense? As soon as if you did square root of 14 in your calculator, you would get, let's see, that. That is not a whole number. Okay, not even close. So that's how that works. You're going to be doing those in your homework. So make sure you have this out in front of you so you can remind yourself of the different 4 steps. And now we're going to flip the page to the other side and talk about the second one, which is the difference of 2 squares. Difference. Difference. That's subtraction of 2 squares. This has a 3 check deal. First, is that a perfect square? Yes. It's x. Check. Is that a perfect square? Yep. Check. Is that a subtraction? Check. So we have a difference of 2 squares. The difference between this one and the other ones on the other side I want you to look at this. These are the same. X plus 2, x plus 2. Same. X minus 7, x minus 7. You never have a positive and a negative. They're either both positives or both negatives. Well, in this case, you actually get the other situation. You get one of each, a plus and a minus. So I still use the x and the 9, but one's plus, one's minus. That's your answer for this problem. And if I show you something, you'll see why. If I were to FOIL this out using our FOIL property, x times x is x squared. X times a negative 9 is a negative 9x. 9 times x is 9x. And 9 times negative 9 is negative 81. So if you notice, this negative 9x plus 9x, that's 0. And you're left with the same thing you started with. Okay, so that's why this works for this situation. Because of the positive and the negative, they cancel each other out, those middle terms. Okay, I just wanted to show you that. You didn't have to copy that down. Okay, now we're going to practice this. Determine whether the binomial, two terms, is a difference of two squares. So check them out. They all have 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Yep, so they're all binomials. Now, is it a difference of two squares? Do you see any we can rule out? Is there any that aren't differences here? Nope, they all have subtraction. You should check that because some people get tricked by that. There's everything's right, but there's a plus. Then it doesn't work. Okay, for some reason looks blurry to me. Let me fix that. Okay, so now you do, what is the perfect square for that? Now remember, if it's an even, you just divide it by 2. So square root of 9 is 3, but then you divide the power by 2 and get that. Square root of 16 is 4, and then the square root of q squared is q. So those are your two things. Now you just need to put them in there where one's plus, one's minus. And that's your answer. Let's look at this. Well, and to check to determine whether, we didn't do our checks. It was like check, check, check. Those are our 3 checks. Perfect square, minus. Let's check this one out. Perfect square, yes, x to the 3rd. Check. Perfect square, no, what part of it's not? The y squared is. It's y. It's a 7. You can't take the square root of 7, so not a difference of two squares. All right, how about this one? Perfect square? Sure is, p to the 4th. Perfect square? 7, It's an odd power. That's not a perfect square. No. Not a difference of two squares. Gotta have 2 perfect squares, not just one. All right, let's look at this. Is that a perfect square? No. The p is. You could have the p. It's this. Square root of 3 is not a perfect square. Not a difference of 2 squares. All right, let's look at this. Is that a perfect square? Yay, finally. 10x. Check. Is that a perfect square? Yes. 2y. Check. Is it a subtraction? Check. I got my 3 checks. Now I've got my 2 numbers. One is a subtraction and one is an addition, and it doesn't matter which one you write first. These could be flopped. That's fine. All right, let's look at this one. Perfect square? Yes, it is. X to the second divided by 2. How about that? Yep. Oh, I was going to write 20. It's not. What's square root of 25? 5. And what's the square root of y to the 6th? Y to the 3rd. Is it, so that's a check, and then it's a subtraction. So we have our 3 check system done. Here's my 2 things. 1 plus, 1 minus. All right. And that's all we got for lesson 8-5. Take care.